Hey guys, I have a bunch of great jokes to tell you today, and I don't know if I should tell you all of them, some of them, and even where to start. So we'll see how far I get. So we'll start with, where do fish like to go on vacation? Finland. What do you call a penguin in the desert? Lost. Why did the giraffe graduate early? His head and shoulders were above the rest. And we'll make this one my last one. Where do polar bears vote? The North Pole. Get it? At a pole, P-O-L-L? Alrighty. So, let's go ahead and talk about the actual math video now, the math parts. So today we're going to be writing equations of lines in slope-intercept form. You have done a lot with slope-intercept form, and now I'm just kind of throwing you some more stuff, throwing more at you. And most of it is going to be about when you're given 2 points, how you're going to write that into your y equals mx plus b form. So we're going to start with we're going to become fluent in Algebra 1 by creating the equation of a linear function. We will concentrate on learning how to form equations in the slope-intercept form that we've been working with. Okay, so a quick reminder, given a linear function f of x, it's expressed in the equation form by, there it is, f of x equals y, which equals mx plus b. So there are 2 parameters. Our 2 parameters are the average rate of change, okay, also known as slope. So I do tend to use the terminology slope a lot in this unit, but remember it's the same thing as average rate of change. Change of y over the change of x, rise over run, and b. B is your y-intercept of the line. Okay, so what we're going to do is we're going to determine an equation in the form y equals mx plus b for these lines. Now, I actually put the graphs in the wrong order. And so we're going to start with the second graph, the one on the left side, rather than the one on the right. Whoops. And so what we're going to do is to write this in slope-intercept form. Hopefully you guys remember when we take a look at this, here we go, sorry, trying to keep everything covered on this one. We have our y-intercept, where we're going to start positive 2, and to get to our next point, we're going to count, we're going to always do rise over run first, so we're going to count up 1, 2, 3, and right 1, 2, okay? And so we get the equation y equals 3/2 x plus 2. And so again, 2 was our starting point, and then it was up 3, right 2. Now what we're going to do very quickly is we're going to do a test. We're going to see and check for a point that lies on the line. So we're going to check by using x equals 2. So when x equals 2, we're going to solve for y. And so when we do that, we just substitute 2 in for x. 3/2 times 2 is 3. So we get 3 plus 2. 3 plus 2 is 5. When we rewrite this as an ordered pair, we have the point 2, 5. 2, 5 lies on the graph. So again, if I go right 2 and up, 1, 2, 3, 4, 5, there it is. It lies right there on a graph. So again, once we come up with the equation, we can check and look for points that lie on the graph. Now we're going to do something similar on the first graph, so kind of backtracking on this one. So on this one, we are going to start by finding slope. Okay, so when we find slope, we go from one point to the next. So it looks like I can go, here's a second point, up 1, but this time I'm going to go left 3, 1, 2, 3. Since I went left, that's a negative movement, so I know I'm going to have a negative 1/3 x. Or I can check by going down 1 and then right 1, 2, 3. I get another intersection exactly on my grid, and so down 1, right 3, again, the down is a negative slope movement, and so I get my negative 1/3 x. But this is the thing. My y-intercept does not intersect very well on that y-axis. So it is b. I don't know what it is. So to find b, what we're going to do is we're going to substitute any point on the line and solve. Okay? When we substitute any point on this line, I'm going to go ahead, I'm going to pick the 0.21. Just going something kind of easy, nothing crazy, okay, for that. So I make my substitutions. I'm going to go ahead and put 2 in for x, 1 in for y. So I have negative 1/3 times 2. Then plus b, because again, we're solving for b. So I get 1 equals negative 2/3 plus b. And so I add 2/3 to both sides. When I add 2/3 to both sides, I get 1 and 2/3. Now, this is the thing. Scroll this up for you guys. What I've noticed with 10 marks and what I've noticed with some other things that I have found online recently, when the y-intercept is written, I've noticed it more often lately that it is written as an improper fraction, not as a mixed number like I have. I can tell you right now, maybe some of my answer keys might have it as a mixed number, but again, we're going to try and switch and do an improper fraction. So 1 and 2/3 as an improper fraction is 5/3. The way that we would check that is 3 times 1 is 3, 3 plus 2 is 5. So 5 is our numerator, and we use the same denominator. So again, for right now, we're going to go ahead and leave it as an improper fraction, not as a mixed number. Now the next thing that we will be doing is when you are given pairs of points, we're going to put it in y equals mx plus b form. Okay, and so again, we're going to do this algebraically, not necessarily with a graphing calculator or to graph these points and go from there. We're going to, again, do things algebraically. So to do it algebraically, the first thing that I'm going to do is I'm going to put this in my formula for finding the average rate of change, formula for finding slope. So this is going to be y2 minus y1 over x2 minus x1. So again, that's y2 minus y1 over x2 minus x1. And so what that looks like, so I'm going to kind of, flip some papers around here so everything's nice and kind of organized. This is what that looks like when I make my substitutions. So again, my change of y over my change of x. Okay, my change is 17 minus 5 over my change of x is 5 minus 2. And then I simplify 12 over 3. 12 over 3 is 4. Now, we still have, if I put this into slope-intercept form, y equals 4x plus b, I don't know what b is. So I need to solve for b. To solve for b, well, you know what? I can substitute an ordered pair in for x and in for y. So just looking up here, pick one of your ordered pairs. I tend to pick the first one unless like they're outrageous numbers, and then I just pick whatever is easier. So really any set of numbers will work. It doesn't matter which one. So when I make my substitutions, again, my y in for the y aspect, so it's 5, 2 in for the x, so, and then plus b. 4 times 2 is 8. And I subtract 8 from both sides to solve for b, and I have b equals negative 3. So now I'm going to rewrite this equation. This time I'm going to put negative 3 in for b, and there we have it. Y equals 4/3. I'm sorry, y equals 4x minus 3. Okay, let's go ahead and try this again on part B. So part B, you guys remember how I said it is the change of y over the change of x? So just so you know, it really does not matter if the second ordered pair comes first or the first ordered pair. All you have to make sure you're doing is that, when you have your ordered pair, that they line up on top of one another. And again, it's your rise over your run, your change of y over your change of x. Those are the key things. So what I'm going to do this time, I'm going to go ahead and show you how, this time on this one, I'm putting 5 over negative 2 first. Minus is a part of the formula, and then 3 over 2. So my change of y, 5 minus 3, over my change of x, so negative 2 minus 2. Okay? The minus, again, represents the change, or finding the difference. When I do my math, I get 2 over negative 4, and I simplify that to negative 1/2. From here, I'm going to go ahead and put this into slope-intercept form. And then again, I realize that b is missing. Okay, so I'm going to make my substitutions. Again, it doesn't matter which ordered pair you pick. Pick whatever is easier for you. I just chose negative 2, 5. So negative 2 in for x, 5 in for y. And then you simplify. So negative 1/2 times 2 is 1. Okay, so we have 5 is equal to 1 plus b. I solve for b by subtracting 1 from both sides. B equals 4. And now I can put this into my equation of slope-intercept form. Voila! Y equals negative 1/2 x plus 4. All right, I have some more examples on the back, so let's flip this over. Magic, here it is again. Again, I have my set of ordered pairs. We are doing the change of y over the change of x. Okay, so negative 4 minus 11 over positive 4 minus negative 1. Okay, doesn't matter which set of ordered pairs come first, but again, make sure the corresponding x and y are on top of one another. Then we do the math going across. So we have negative 15 over 5. Simplify that to negative 3. And then we put this into our equation of slope-intercept form, and we realize we need to find b, solve for b. So we're going to pick one of our ordered pairs from the top and make our substitutions and solve. So again, I'm going to put 11 in for y, just like that, negative 1 in for x, just like that. And we're going to solve for b. Negative 3 times negative 1 is positive 3. Subtract 3 from both sides. I have b equals 8. My last step here, I just put this into slope-intercept form. I have y equals negative 3x plus 8. That's it. I'm going to see how well you guys are kind of understanding this concept. So let's have you guys try D on your own. Okay? Use A, B, and C. Okay? Use these to help you as your guide when you are setting up your equation. Okay? Again, if you are struggling with how to find B, go back and look at notes number 1. That should help you. All right, I have one more problem here at the very end, and this is a story problem. So let's read this story problem. We have a car is traveling along a straight road. After 1 hour, the car is 72 miles from Chicago. After 3 hours, the car is 188 miles from Chicago. We're going to determine an equation for the distance, D. The car is from Chicago after H hours if the relationship between D and H is linear. Okay, so what that means is the first thing that we're going to do is we are going to pull out our ordered pairs. Okay, we're going to find those two parameters that we have going on. So the first one is after 1 hour, the car is 72 miles from Chicago. Okay, so that is my first ordered pair that I'm going to write down. Sorry, trying to get my paper in the right location. So I have the point 172. After 3 hours, okay, the car is 188 miles from Chicago. Okay, that's my second ordered pair. 3, 188. The next thing I want to do is talk to you guys about how in this story problem they are using the variables d and h and not x and y. And so for this problem we're going to go ahead and use d and h instead of x and y. We just have to figure out, well, which one is x and which one is y when we substitute. Okay? So one way, typically when they talk about whatever they talk about first, that's your x. Whatever they talk about second, that's your y. Or, you think about a linear graph, or I'm sorry, any kind of graph. Time is always horizontal. So just knowing that whenever you're dealing with time, that's your x, you're good to go. Okay? So we can go ahead and remember that as we create our equation. So we're going to find slope. Remember slope? This time, change of distance over the change of hours. Change of y over the change of x. Okay. Make your substitutions. So 188 minus 72 over 3 minus 1. Okay, remember xy, xy. Now we simplify. We do our math. 116 over 2. One more step to simplify. 58. From here, okay, it has said determine an equation. Well, they didn't say what equation. The only one that we know right now, slope-intercept form. But again, we're not using slope-intercept form. We're going to remember that d is our y, h is our x. H is time, our hours, that's our x. Okay? Plus b, we don't know our starting point. So we do know one of our points, 1 and 72. Again, just pick something that's easy, whatever works. Both will work if you want to try it. But 58 times 1 is 1. We solve for b by subtracting 58 from both sides. We have 14 equals b. Okay. Then the last thing that we can do is we can make our substitutions. Now we have our equation d equals 58h plus 14. And then our equation, again, we're using d and h instead of x and y because that's how the story problem gave it to us. Okay, they were talking about d is distance, h is hours. And the other thing to think about it is for every hour, you're traveling 58 miles. Okay, and then d is your total distance. All right, that's it for these notes. I hope you enjoyed, and I hope you do well on getting Part D correct in class. We'll check that next time I see you. Bye.